When you sit quietly and look around, you notice things that feel obvious, things that feel certain. A table holds your hand, the floor holds your weight, the walls stand tall, the ceiling stays put. Your body itself feels solid, reliable, undeniable. But here's a question that almost no one ever dares to ask, and yet it is so simple that a child could pose it. Why doesn't all this collapse? Why doesn't matter, made of tiny charged particles, simply crumble into nothingness? Why do atoms exist in the precise way they do, holding space between them, giving structure to everything we touch and see? Think about that for a moment. The universe, at its most basic level, is composed of particles that attract and repel each other. Opposites pull like tiny magnets drawing together. And yet, somehow, these particles do not crash together. They do not disappear into a chaotic singularity. How is this possible? It is the kind of question that immediately unsettles the mind. Most explanations you have been offered, in classrooms, in books, quietly avoid the real issue. Here is an atom, they say. This is the nucleus. These are electrons. They orbit like planets. And we nod, perhaps impressed, perhaps satisfied. But look closer. The picture tells you what things are called, but it does not tell you why those things exist at all. If electrons are attracted to the nucleus, as the rules of classical physics dictate, then they should collapse into the center, immediately. End of atom, end of matter, end of you. And yet we are here. That tells us that something extraordinary is happening, something completely outside the intuition that guides our daily lives. To begin to understand it, let's leave the atomic world for a moment. Imagine a crowded room. Some people want to push together, others want their personal space. If everyone only moves inward, the crowd crushes itself. If everyone only moves outward, nothing stays connected. Stability arises only when opposing tendencies find balance. Atoms, in their invisible dance, behave similarly. There is a tremendous pull inward. The positive charges and the negative charges cannot help themselves. But there is also resistance. Resistance built into the rules of the universe itself. Not a scaffolding, not a glue, but a natural law that forbids certain configurations. This resistance is not a suggestion. It is an absolute. The electron cannot be confined perfectly to the nucleus. Why? Because the universe itself refuses. There is a rule, subtle and fundamental. You cannot know both the position and the momentum of a particle with complete precision. It is not a matter of measurement. It is a matter of existence. Confining an electron tightly costs enormous energy. Push it too close, and nature pushes back with an energy too large for the attraction to overcome. So the electron settles. It spreads out. It exists as a probability, a cloud of possibility, neither here nor there, resting in a compromise that is dictated by the universe itself. That compromise is the reason atoms do not collapse. That compromise is the reason you exist. Notice the implication. Nothing holds up matter from the outside. No secret scaffolding, no hidden glue. Matter exists because collapse is forbidden, not because it is forced. The table you touch, the chair you sit on, the person across from you, they all exist in a delicate balance enforced by invisible rules. That is why the solidity you perceive is not solidity at all. It is resistance. Resistance built into the universe, programmed into the very way atoms interact. Your hand does not pass through a table, not because it is solid in the classical sense, but because the rules of existence themselves do not allow those atoms to occupy the same space. They refuse, and they will not yield. Most people never think about this. They are taught the names of particles, the positions of electrons, the labels, the diagrams. But these explanations skirt the reality, which is far stranger and more profound. Reality does not obey human intuition. It is not built for our comfort or our comprehension. At the smallest scales, the universe follows rules that can seem absurd, that contradict the common sense we rely on in daily life. And yet, those rules allow everything to exist at all. The stability of atoms is a profound testimony to the subtlety and precision of the cosmos. Now let us reflect. That balance we see at the atomic level, attraction and resistance, is mirrored throughout the universe. Stars shine because gravity pulls inward, but pressure pushes outward. Life exists because countless processes balance growth and limitation. Even thought itself, the development of ideas, depends on tension, contradiction, opposition. Stability is never about the victory of a single force. It is always about compromise, about equilibrium. And the atomic world teaches us this lesson in the most literal and uncompromising way. Consider what would happen if one tiny constant were different. Electrons would fall into nuclei, atoms would collapse, chemistry would vanish, no molecules, no water, no DNA, no life, no consciousness to ponder any of this, and yet here we are, improbably perched on a narrow edge of possibility, made entirely of particles that exist only because the rules do not allow them to behave otherwise. The universe is not generous, it is strict, precise, and astonishingly clever. And so, when you ask, why do atoms exist? You are not merely asking about physics, you are asking about reality itself. You are peering behind the curtain to see the rules that make existence possible. You are confronting the fragility of everything you take for granted. And in that confrontation, there is awe, there is humility, there is a profound curiosity that cannot be satisfied by diagrams or labels. There is the realization that human intuition is fragile, inadequate, charmingly mistaken, when faced with the fundamental nature of the world. Atoms exist, not because they are commanded to, not because they are forced to, but because collapse is forbidden. This is an idea at once simple and utterly mind-bending. It transforms your perception of solidity, of matter, of yourself. And the more deeply you consider it, the more astonishing it becomes. Every table, every tree, every star, every living being rests upon this fragile, elegant balance. And when you understand it, you cannot look at the world the same way again. Perhaps the most unsettling part is that this understanding does not give closure. It does not resolve the mystery entirely. We see why collapse is forbidden, but we do not fully comprehend why the rules are the way they are. That is a question that extends beyond physics into philosophy, into awe, into wonder, and that is precisely where Feynman would leave you, not with an answer, but with a gaze into the vast, intricate machinery of reality, inviting you to think, to question, to marvel, to recognize that the universe is stranger, deeper, and more beautiful than words can capture. So the next time you touch something solid, remember, you are not touching matter in the way your senses suggest. You are feeling the universe enforcing its rules, quietly, relentlessly, allowing atoms and therefore you to exist at all. And perhaps, in that awareness, you will understand why the question of atomic existence is not just physics, but philosophy, poetry, and the ultimate adventure of curiosity itself. And when you walk away, you will carry with you a whisper of the universe's quiet, perfect, unimaginable balance.